In this video, I'm going to show you how to find a general and principal solution of any trigonometric equation. Okay, so now let me explain how to find those. Now, let me show you how to what is the general solution of sine theta is equal to 0 and how to find it. Okay, now you see sine theta is equal to 0. Its general solution is given by theta is equal to n pi. Okay, theta is equal to n pi, where n belongs to z. Z means set of all integers. Okay, so let me explain why it is. Now you see sine theta, its value is 0 at 0 degree. Theta is equal to 0. It is 0 at pi. It is 0 at twice pi. It is 0 at thrice pi. Okay, similarly it will be 0 at minus pi, minus twice pi, dot so on. Okay, so you can see all the solutions are integral multiples of pi. Okay, so that's why we can say general solution of sine theta is equal to 0 is equal to n pi, where n belongs to z. Okay, so now let me show you again using the quadrant. Okay, suppose this is x axis, this is y axis. Suppose we have a point here, this is suppose P on a terminating line. This is terminal line, you can say OP, where its coordinate is x comma y. So then obviously this is y, this height is y, and this length is x. Okay, suppose we have considered OP is equal to r. Now let us take this angle is theta. Okay, this is theta, this angle is theta. Then from this triangle, suppose this point is M, suppose this point is M. Okay, so from the triangle POM, so we can write sine theta is equal to sine theta is equal to, you know, sine theta is perpendicular by hypotenuse. So here perpendicular is y and hypotenuse is r, so it will be y by r. Okay, so perpendicular by hypotenuse. And for sine theta is equal to 0, so we can write y by r is equal to 0. And in this case r cannot be equal to 0, because if r is 0, then this term will be not defined. Okay, then this fraction will be not defined, y by r will be not defined. So that's why r cannot be equal to 0. So if r is not equal to 0, then y by r can be equal to 0 if and only if when y is equal to 0, if y is equal to 0. Okay, so that means this must be 0 here, this one, this y is 0, y must be equal to 0. That means this perpendicular is 0. That means this point P, when y is equal to 0, then this point P must be lying on x-axis. Okay, must be lying on x-axis. So suppose this is the quadrant xy, this is x dash, this is y dash. So when P lies on x-axis, then theta may be equal to 0, or if it is lying on this side, it may be equal to pi. Okay, it may be also equal to twice pi also, may be equal to thrice pi, okay, and so on. That's why the general solution of sine theta is equal to 0 is theta is equal to n pi. Therefore, P lies on x-axis and it is possible when theta is equal to n pi, where n belongs to z. So we can say the general solution is theta is equal to n pi. Now what will be the principal solution of sine theta is equal to 0? Okay, so theta is equal to n pi. Theta is equal to n pi. It is general solution. So principal solution are the values of theta which are lying between 0 and twice pi. So theta must be greater than, maybe greater than equal to 0 or less than twice pi. So then its value will be called principal solution. Okay, in this case sine theta is equal to 0. So sine theta is equal to 0 at theta is equal to 0, at theta equal to pi, and at theta equal to twice pi, and so on. But we have to take only these two, 0 and pi, if we need to find a principal solution, because these two lies within this interval. Okay, so theta can be greater than equal to 0, so close interval here, and open interval here, twice pi, but less than twice pi. Okay, so principal solution of sine theta is equal to 0 is given by theta is equal to 0 or pi. Okay, so now let me show you how to find the general solution of cos theta is equal to 0. Now general solution of cos theta is equal to 0. So how to find the general solution of cos theta is equal to 0? Okay, general solution of cos theta is equal to 0 is theta is equal to twice n plus 1 into pi by 2. Okay, so this is the general solution of cos theta is equal to 0. Now let me explain how. So let us take the quadrant again. This is the x-axis, y, x dash, y dash. Okay, and here is the origin O. So this is the terminal line. Okay, this point is P. Then let us draw a perpendicular here. So if the coordinate of P is x comma y, then this is this height is y, and this length is x from here to there. Okay, and let us take this is r, OP is equal to r. Okay, and this angle be theta. So now cos theta is equal to 0 also can be written as, so we know cos is based by hypotenuse, so we can write x by r is equal to 0. Since r cannot be equal to 0, hence x must be equal to 0 in this case. So if x is 0, then the point P, this point P must be lying on y-axis. Okay, this is x, this is y, so this point P must be lying on y-axis, either on this side or this side maybe. Okay, this P must be lying on y-axis. So it is possible when theta is pi by 2 or 3 pi by 2 or 5 pi by 2 or 7 pi by 2. So these are all odd multiples of pi by 2. Okay, so at those values cos theta will be equal to 0 at theta is equal to odd integer into pi by 2. Okay, and if n belongs to z, then odd number can be represented as twice n plus 1. That's why general solution of cos theta is equal to 0 is given by theta is equal to twice n plus 1 into pi by 2, where n belongs to z. So hope you have understood this. So we know principal solution, this is the general solution, this is the general solution. And what will be the principal solution? We know principal solution lies between 0 and twice pi. It is greater than equal to 0, less than twice pi. So that's why principal solution of cos theta is equal to 0 maybe pi by 2 and 3 pi by 2. These are the principal solution, pi by 2 or 3 pi by 2. Okay, so that's how we can find the general and principal solution of cos theta is equal to 0 degree. So hope you have understood this. So now let me show you how to find tan theta is equal to 0 and cot theta is equal to 0. Okay, now general solution of tan theta is also theta is equal to n pi. Okay, it is same as sin theta is equal to 0. Okay, general solution of sin theta and tan theta equal to 0, both are same, where n belongs to z. Okay, now let me explain. Now you see, from this diagram we can say tan theta is equal to 0 implies y by x is equal to 0. So here you see, here definitely x cannot be equal to 0. Okay, x cannot be equal to 0. In that case, this fraction to be equal to 0, y must be equal to 0. Okay, so we can write y is equal to 0. If y is equal to 0, this point P must be lying on x-axis. This is x-axis, so maybe lying on this side or maybe that side. It is possible when theta is equal to 0, when pi, when twice pi, when thrice pi, when theta is equal to 4 pi, okay, and so on. So that's why general solution is theta is equal to n pi, where n belongs to z. Okay, so I hope you have understood. So what will be the principal solution? Okay, principal solution, we know principal solution is greater than equal to 0, less than twice pi. So in this case, only possible values of theta lying in this range is are 0 and pi. Okay, this must be the principal solution for tan theta is equal to 0. Okay, so hope you have understood this. So general solution of cot theta is equal to 0. So what is the general solution of cot theta is equal to 0? It is theta is equal to twice n plus 1 into pi by 2, where n belongs to z. Okay, so this is the general solution for the equation cot theta is equal to 0. Okay, so from this diagram, from this quadrant, so we can write cot theta is equal to 0 implies base by perpendicular, that is x by y is equal to 0. As in this case y cannot be equal to 0, so x will be equal to 0. So that the point P, this point P must be lying on y-axis. Okay, it must be lying on y-axis. So it is possible when theta is equal to pi by 2 or 3 pi by 2, 5 pi by 2, and so on. That means odd multiple of pi by 2. So that's why general solution is theta is equal to twice n plus 1, which gives an odd number, into pi by 2. And principal solution, in case of principal solution, theta must be lying between 0 and twice pi. So greater than equal to 0, less than twice pi. So principal solution are principal solutions are here pi by 2 and 3 pi by 2. So hope you have understood this. Now let us find the general solution of sine theta is equal to k, where k belongs to the range of the function sine theta. Okay, so this k, we know the range of sine theta is close interval from -1 to +1. Okay, so that's why k must belong to this. Okay, so we have an equation sine theta is equal to k. Okay, is equal to k. Suppose alpha be the smallest possible angle such that sine alpha is equal to k. Then from these two we can write sine theta is equal to sine alpha. Okay, so if sine is equal to k, so it is obvious that there will be infinite solution of this equation. Okay, there will be infinite value of theta for which sine theta is equal to k. But we have taken that alpha is alpha be the smallest possible angle for which sine alpha is equal to k. So from comparing these two equations, sine theta is equal to k and sine alpha is equal to k, we can write sine theta is equal to sine alpha. Okay, so then it implies sine theta minus sine alpha is equal to 0. Okay, so using sine c minus sine d formula, here we can write that twice cos theta plus alpha by 2 sine theta minus alpha by 2 is equal to 0. Okay, so which implies cos theta plus alpha is alpha by 2 into sine theta minus alpha by 2 is equal to 0. Okay, is equal to 0. Now here you see, if the product of these two is equal to 0, then either any one of them must be 0 or both of them must be 0. Okay, so we can write cos theta plus alpha by 2 is equal to 0, or sine theta minus alpha by 2 is equal to 0. Now if you consider this theta plus alpha by 2 as a whole theta, then the general solution of cos theta is equal to 0 is what? You remember that theta is equal to, or instead of theta we are taking here theta plus alpha by 2, and general solution for cos theta is equal to 0, it was n pi twice n plus 1 into pi by 2. But here instead of n we are going to take twice m plus 1 into pi by 2. Okay, twice m plus 1 represents odd number, odd integer, pi by 2, odd multiple of pi by 2 here, where m belongs to z. Okay, so if you simplify this, then you will get theta is equal to twice m plus 1 into pi minus alpha. Okay, If you simplify this equation, then you will get this. Okay. So similarly, this angle taking theta minus alpha by 2 as theta, then sine theta is equal to 0. The general solution is n pi. So instead of n, we will take here m pi. Okay. So theta minus alpha by 2, let us take this one as m pi, where m belongs to z. So simplifying this, we will get theta is equal to twice m pi plus alpha. Okay, if you simplify this, you will get this one. So here you see, if you compare these two cases, okay, if you compare these two cases, these two values of theta, then you can see here it is odd multiple of pi, and here it is twice m. Twice m is even. Okay, even. And here we have seen this is minus, and here it is plus alpha. So let us replace the twice m plus 1. So we have got in one case twice m plus 1 into pi. In another case we have got twice m pi. Okay, here minus alpha, here it is plus alpha. So here you see, when it is odd multiple of pi, then we have got here minus alpha. When even multiple of pi, we have got here plus alpha. So combining these two results, we can write theta is equal to n pi, so plus minus 1 to the power n into alpha. Okay, where n belongs to z. So we have replaced the twice m plus 1 and twice m by n. Okay, that means here in this case n may be positive, or n may be even, or n may be odd. If n is even, then in this case you see, when n is even, so this term will be positive. When n is odd, then this term will be negative. Then we will get this result. When n is even, we will get this result. Okay, so this is the general solution for sine theta is equal to k, where k belongs to the range of the function sine theta. Okay, so we have got the general solution. This is the general solution. Okay, now let us obtain the general solution of cos theta is equal to k, where k is greater than equal to minus 1, less than equal to plus 1, and that means k is in the range of the function cos theta. So what was the range of cos theta? Range of cos theta, we know that is also same as sine theta. Okay, so let us suppose alpha be the smallest angle such that cos alpha is equal to also k. Now let us compare these two equations. This one, cos alpha is equal to k, and cos theta is equal to k. Comparing these two, we can write that cos theta is equal to cos alpha. Okay, so we have compared these two equations, then we have got cos theta is equal to cos alpha. So here you see, it implies cos theta minus cos alpha is equal to 0, or we can write cos alpha minus cos theta is equal to 0. Now let us apply cos c minus d formula here, which gives 2 sine alpha plus theta by 2 sine theta minus alpha by 2, which is equal to 0. Okay, so here, okay, Now you see, this implies sine alpha plus theta by 2 sine theta minus alpha by 2. Okay, now if you observe this, then you can see this is product of these two is equal to 0. So either both of them must be 0, or each of them, any one of them must be 0. Okay, so let me divide the page here. Okay, so from here we can write either sine alpha plus theta by 2 is equal to 0, or sine theta minus alpha by 2 is equal to 0. So if you consider this one as theta as a whole, theta, then we know the general solution of sine theta is theta is equal to, here instead of theta we can write here alpha plus theta. Okay, alpha plus theta by 2 is equal to n pi, where n belongs to z. Okay, so this implies that theta is equal to twice n pi minus alpha. On the other hand, here we will get theta minus alpha by 2, again n pi, where n belongs to z, which will imply that theta is equal to twice n pi plus alpha. So if you compare these two results, we will get theta is equal to twice n pi plus minus alpha. Okay, so this is the required general solution, okay, where n belongs to z. So hope you have understood this. So now general solution of tan theta is equal to k, where k belongs to r. So we know the range of the function tan theta is r, that's why k belongs to r. We have taken k is such a value which belongs to r. Okay, set of all real numbers. Okay, so let us suppose alpha be the let me use another color here. Let us suppose alpha be the smallest angle for which tan alpha is equal to k. Now if you compare these two equations, then you can write tan theta is equal to tan alpha. Tan theta is equal to tan alpha. Sine theta by cos theta. We know tan theta is equal to sine theta by cos theta. So here sine alpha by cos alpha. So again we see here cos theta and cos alpha, these two cannot be equal to 0. Okay, otherwise this equation will be not defined. Okay, its term on the terms either side of the equation will be not defined. So these two cannot be equal to 0. Now it implies sine theta into cos alpha is equal to cos theta into sine alpha. So after cross multiplication we have got, now it can be simplified as sine theta cos alpha minus cos theta sine alpha, which is equal to 0, and it gives sine theta minus alpha is equal to 0. Okay, so sine theta minus alpha is equal to 0. So here you see we know the general solution of sine theta considering theta minus alpha as theta. We will get here general solution will be theta minus alpha will be equal to theta minus alpha will be equal to n pi, okay, where n belongs to z, okay, n belongs to z. That's why we can write theta is equal to n pi plus alpha, n pi plus alpha. So that is the general solution of tan theta is equal to k, okay. So this is the general solution, okay. So similarly we can find the general solution of cot theta as well, okay, and similarly we can find general solution general solution of cot theta is equal to k, okay, or you can say if you write cot theta is equal to cot alpha, okay, then theta will be again n pi plus alpha, okay, n pi plus alpha, where n belongs to z, because you see tan theta, if you can write tan theta is equal to tan alpha, then you can write 1 by cot theta is equal to 1 by cot alpha, yes, and which implies cot theta is equal to cot alpha. So if this equation implies this one, so their general solutions must be same, okay. So hope you have understood this. So this is the general solution of tan theta is equal to k, or you can say tan theta is equal to tan alpha, also the general solution of cot theta is equal to cot alpha. So that's how we can find the general solutions. So in the next video we are going to solve the problems of exercise 3.4 of NCERT textbook of mathematics class 11, okay. Thank you for watching my video, and if it is helpful then please do subscribe my channel, okay.